Hey everybody, what's up? Lars here. This is going to be the second of what I think at the end of the day is going to be 5 videos that you're going to get. And that sounds like a lot, and I'll explain in a second. But I want to do a video for each segment of the 3 segments of the slides. As you know, Unit 3, bigger unit, 3-week unit, not a 2-week unit, basically breaks down into functions, file I/O, and libraries and modularity. And today we're going to do file I/O, and we're going to talk about using files to keep our data. But 2 little extra ones. I think what I'm going to do is I'm going to make tonight and make tomorrow when I do libraries and modularity, I'm going to make those quick hits. And I'm going to do a special video where I do my own homework assignment. And you see me from scratch go through a process that's very similar to the assignment you're going to have to tackle for Unit 3, so that you're not, dropped in the middle of the ocean. You actually see something similar to what I intend to do. Then lastly, I'm going to shoot another video where, as promised, I use the new tools that we're learning this unit, and I rewrite the Euler 6 problem, so that we do it with functions and that we do it with libraries. And at the end of the day, we're going to end up, doing it all in one line in a program, which sounds crazy, but it's true. You can do it all in one line. And then maybe we'll get nuts and I'll do it all in one line on the interpreter window, because if you can use these things called list comprehensions and do the whole thing in one line. But I digress. Right now we want to talk about file I/O and files. And what I usually do, and I'm going to give you a condensed version this go round. Well, the first thing I'm going to tell you about is the insane week it's been, because the Islanders are a point out of the playoffs. So now's their chance. Now there's a bunch of teams not playing well. Rangers aren't playing well. Some other teams aren't playing well. So now is their chance to do something. They lose to the Flames. Okay? They're winning by a goal with a minute left. They give up a goal. They go into overtime and they lose. So they got a point, but they lost the game. Then they lose to the Blue Jackets. So I'm pissed. I'm like, season is going downhill. Historically, if you just look at the stats, the Islanders are the worst defensive hockey team of the past 20 years. Goals against, shots against, I'm not going to get crazy. Anyway, last night, they played the Rangers. I figure I'll watch. What the hell? They shut them out. They beat the Rangers 3-0. Now they have back-to-back games. They always lose the second half of back-to-back games. And they played the Hurricanes tonight, and they beat them 3-0. Greiss net, too, the other goalie, the second goalie that we have, who's not very good. So all of a sudden now, the Islanders have gotten 4 points in 48 hours and are in the playoffs. They took over the last spot in the playoffs, so they have a playoff spot right now. This season is nuts. Anyway, I don't want to go nuts on that here, but you do need to see something. Hold on a minute. Now, they still don't have the Carolina game up. You can never shut out the Rangers enough. All right, that's enough. You needed to see that. Tonight is going to be file I/O. It's the second video, the second part of your Unit 3 slides. And I'm shooting this Friday night. This is going to be a psycho video weekend for me. I'm just going to keep doing videos because I want to get you all your resources super early. Because next week, and you'll know, I'll probably do a video from there. I'm going to Baltimore to the SIGSI conference next week. And I want to get you all these resources because I want to get you your homework assignment so you can get working on it and you can have a lot of time to have it. But before I can do that, you need to get this video, you need to get libraries, and you need to get that 4th video because it's going to have an example problem. So you're going to want to watch that too. So if you're one of those people who have been watching the different unit videos and not watching the extra ones, make sure you watch the extra ones this go around. All right? All right. Then, without any further ado, I'll just do this, and then this I think I will kill. Boom, because I'll have it again. All right, I already set up some code for us, as you can see. And the story I was going to tell you before I got into my Islander rant was that when I was a kid, and I went to school back in the late 80s, I went to school for computer science at St. John's University. And They didn't really have their head wrapped around how to do computer science education yet. Computer science departments pretty much hailed from math departments in the late 60s and the 70s, and most of the kids who took these classes in the 70s, they already had a little bit of background, and they just wanted to learn how to program really quick and then do things with discrete mathematics. So instantly they would take a programming class. Well, traditionally, that's still the way we do it, but it's wrong because you don't really have an intro. Okay, you're 18 years old, you're interested in computer science, you come to university to learn, and we skip a whole section of what computer science is for, what it really does, and we go right into here, we got to teach you how to program right away. So it's a crummy way to do that. We still do it now, 30 years later, the same way we did in the 80s. And then we do data structures just like we did in the 80s. And then back in the old days, it was Wild West. Then you would do logical design, system architecture, compilers, operating systems, whatever, and a bazillion different language classes. So today you don't really have a bunch of different language classes. We're what's called language agnostic. At the end of the day, we push you towards Java for object orientation, C and C++ for an imperative language and learning. Python for the beginning for education is now being taught in 6 of the top 10 computer science schools. So Python, because it gets out of your way syntactically and it lets you think about logic and some other stuff, okay? But back when I went to school, it was all Fortran, Pascal, I know I'm dating myself, COBOL, RPG, report generator language, this, C. C was very popular at the time. C++ wasn't even around. It was just coming out in 1988. A guy named Bjarne Stroustrup working for AT&T extended the C programming language so that you could do object orientation. It was called C++. But I digress. The whole reason I'm telling you this is because in all my different language classes, they would pretty much go over the same thing. And as you took all these classes, you would abstract what was the same about all the different computer languages. There's always a way to deal with arrays. There's always a way to deal with functions. There's always a way to deal with blah, blah, blah. But one thing they never did was file I/O. And I thought it was the weirdest thing in the world because when you go out into the real world, your boss is not going to walk into the room and say to you, generate the first 500 Fibonacci numbers. Or, take the natural numbers from 1 to 500 and find me the squares that divide into... It's not going to happen. What's going to happen is you're going to get your data in the form of a file. And you have to learn to read in the data from that file. Then do your analysis or look for something in the data or do something like that. And then write it out to another file. Okay? Data is always done with files, like our programs, which are the codification of our logic, and something that we can end and shut our computers off, and the next day when we come down, get again. Well, that's the same thing as a file as far as data is concerned. It's a durable store where I can keep my data. Okay, it's a file, and you've been familiar. If you're a computer user, you're familiar with files. That's basically all it is a permanent store where you can keep your data. So we want to learn how to work with those things and get the data out of the files, use them in our program, and then either find our answer and throw our hands up and cheer or write it out to another file. So we're going to start with the basics. And we're going to use what we call a sequential file, which is just character-based, like a string. It's all characters, and you read one after another. When you read one, you get ready to read the next, read one. That's why it's called sequential. Okay? So the first thing we're going to do is I'm going to look at a file, and it's right here. I'm going to show it here in my file system called small e22. And you get the name because it's the data from Euler 22. Okay? And it's called small because I cut it down in size for, in order to do this example. So what I'm going to do is I'm going to read that file into the program so we can use it. How am I going to do that? I'm going to create a variable. I'm going to assign it the name of the file. Okay? Then I'm going to come down here and I'm going to create a file object or a file handle. I'm going to have a variable f, and I'm going to assign it the results of the open function. And I'm going to open, I put the variable in file, so I get small e22, comma, and then I say r. And the reason I say r is because I want to read. Okay, we're going to see later. We're going to use a w to write. But right now I'm going to read. Okay, then I grab a variable called data, and I assign it, ready, f, which is my file variable, dot, remember we can run those little mini programs like we did on strings? We call them methods. Well, you're going to run a little method on your file object here, and you're going to run read. And what it's going to do is read the entirety of the file and stick it in that variable data. So if it's a string, however long that file is, it's going to be stuck in that one string. And if we come down here and double click, you can see it's pretty good amount of names. Okay? So let's read that in, and we're going to see what it actually looks like. So we're going to read it in, and then we're going to close the file. So really there's three things going on here when you're dealing with reading a file. You're going to open the file, then you're going to read the data from it, then you're going to do what I call being a good citizen, and you're going to close it. Because until you close it, the memory's all out there, and it can't be reused for something else. Now, back in the 80s when I was dealing with computers and computer science, memory was precious. Okay, we were very careful to give our memory back and not have memory leaks in our programs, and it was a limited resource, so was processing, to be honest. So we had to come up with, clever ways. Nowadays, we're lousy with memory. You can use memory till the cows come home and you're not going to waste it. We have gigs upon gigs upon gigs upon terabytes of data now, memory to use, I mean. So you don't have to be as stingy and crazy with your memory as like guys in my age group are, because of the way we were taught. That said, it's a good idea to close your files because you want to be smart about it, and you don't want to leave that memory out there wasted. Okay? So I always call it being a good citizen, because if you don't close it, then nobody else can use it. If you're in a system where other people might be going at these resources, until you close it, nobody else can use it. So what I'll usually do is I'll open up a file, read everything from it, and then close it, and boom, you're done. Then you don't have to worry about it. All right? So let's run this and see what we get. All right. Let me get things in a place where we can read and write. So you can see all the names that are in that file are in that one string because I just printed data. Okay? Now, if I did a len on it, not a George, a len, it would say 2083, but that's not how many names are in there. That's how many characters, okay? Because it sees it all as one big, long string. All right? So, pretty good. We've told Python what file to go grab. We opened it up. We read it in. And now I have all of that in a variable. But right now, I only have it in a big string, okay? I really want to put it in another form so that I can use it and I can do something with it. So what we're going to do is we're going to clean the data. All right, let me put these, because I have a bunch of code written for us in this down there. What we do when we clean the data is we're going to take that big string and we're going to manipulate it, and we're going to put it in a form where we can use it. And the best thing to do is to take all those names and put them in a list so that each name is in an individual spot in the list. And the way we're going to do that is we're going to use two commands. We're going to use one called replace. And what replace is going to do, you can see data, I just make equal to data again, but I run replace on it, and I replace the double quotes. You see these double quotes in here? I replace them with nothing. That's just dash, dash, boom, boom. Two single quotes right in a row. All right? What I'm going to do is I'm going to zotz that part out, and we're just going to do the replace, and then we're going to look at our data. I don't want to look at the len, though. I want to look at the actual data at first. So I'm going to do the data. All right? Let's rock and roll. All right, now, what do you notice? You notice down here, we had the double quotes, right? Here, now we don't. Now we just have names separated by commas, which is perfect. We've gotten rid of our doubles. Now, we just have names by commas. That's perfect for what we call split. Split has two things that are special about it. One, if you have a really big string, you can run the split on it and tell it where to break. And we here are telling it we want to break at the comma. We call that a delimiter. We want to use the comma as a delimiter. So every time there's a comma, we're going to split that string up. And what are we going to do? We're going to put it in the variable data. But now there's a difference. Data is not going to be a string anymore. The return value of split is a list. So we're going to have a list. You remember Unit 2, the difference between a list and a string. We're going to have a list where every item in this is a name. So now when I run it, watch this, I get a list. You can see how it starts with the bracket, and every name is a string surrounded by single quotes. All right? So now I've read in that file, and we've cleaned up the data So now I have it in a list and I can use it. You may be saying, who gives a rat's rear end? Well, now we have it in a usable form. So now we can do something with it. We can count it. We can look through the list for a certain name. We could do all of these different things. We're going to do it right now. Watch. I can search through the list right now. Okay? And that's exactly what we're going to do. We're going to search through the list. I'm going to create a counter. And I'm going to say I, for I in data, it's just, the list. I don't need to use range or anything like that. I have a list. I'm going to iterate through it. Then, and this is a little wrinkle, I'm going to click my counter. Now, you're used to seeing C assigned C plus 1, okay? But that's a little shortcut as far as counters or accumulators are concerned. It assumes that doubles up, okay? So you just use plus equal, and it just adds 1 to C, all right? Instead of assigning it 1, it'll add 1 to it by using that operator right there, the plus equals. Then what do? Then I come down here, and I say if I equals Anna, and I know there's a name in here, Anna, and I can't find it, and I can't see it, but that's okay. And I'm going to print Anna's name and the spot where we find her, and then at the end, I'm going to print my counter, but also, I'm going to do it the more Pythonic way, is I'm going to just run a len on the data, and a len on a list is going to tell me how many items are in the list. Hopefully, those two are the same, otherwise we got some problems. Okay, let's run it. Hey, let's run it and find out. All right, as you come down here to the bottom, you can see Anna was found in the 181st spot. Where are you, Anna? Oh, there's Eva. I have such bad eyes. And usually I can't find these things. Come on. I hope it's not split up. Is it split up? 181 out of 235. It's got to be right up here, around here. There's Anne. They're torturing me. Ashley, I'm not going to waste our time. Anyway, 235 is what I got when I used my counter because I printed C, but when I did the len, it's also 235. So I know my logic in there is working well. Okay? Now, this may seem incredibly simple to you. We took a cheesy list of names and we threw it in a list and we ran through it and searched for a single one. But this is the beginning of data analysis. I mean, you could grab a list of 5 million names and look to see if certain things are in there. Okay? It'll run just as fast. You'd be surprised how fast these things go. And this is, while simple and while we're learning, this is analysis. You just examine the contents of a file and look to see if it contained the name Anna, and it does. And you know of the list of names that are in that file, it's in the 181st spot. That's usable information. Okay? So that's how we work with sequential files. You bring them in, you open them, then you read from them, then you close them, and then you take that data and you clean it up, and you put it in a usable form. Split and replace are going to be your best friends because you're going to get a lot of files that are going to come in that are, CSV, comma separated value. Now, later when you get more sophisticated and you get through the next couple of units, you're going to know there are libraries out there that allow you to use already written code and grab CSVs and do things along those lines. But this is a real simple way in 2 lines to just process your own CSV and do it yourself. Okay? So that, and you don't have to worry. Don't type any of this. I'm going to take this code and I'm going to put it on Sakai for you when this video is over. So you got no worries. All right? There's 2 more things that I want to go through. One is a neat little shortcut. I'm going to 1, 2, 3, zots that out. That gives you another way to deal with files. I can leave that there. And it's called the with construct. And basically what I do here is I have a file called numbers2.dat. I'll show it to you. Numbers2.dat. And as you can see, it's just 12, 23, 34, 45, down the line right there. All right, real simple. What I'm going to do here is I'm going to read it in, and I'm going to print it out line by line. But I'm using what's called the with construct. Okay? I say with, and then I do my open command. I say, hey, go grab numbers2. This time I just use the string. I didn't create the variable. And open it for reading. And then say as f. So our variable is going to be f. All right? And then I iterate for line. Now, that's just a variable. That could be anything. That could be dog, cat, I. It doesn't matter. For line in f, print the integer version of the line. Okay? So what's going to happen here is it's going to go line by line through that file and print it out. All right? What's missing here? What are the two things that you don't see? You don't see a read anywhere, right? The read is kind of implicit. Every time you go through the loop, you're going to read the next line. All right? You're going to start out with line 1 and keep going until you get done. What else is missing? The close. You don't see a close there. The neat thing about with is that when you're done iterating through the file and it gets to the end, it automatically closes the file for you. So you're done. I know, I just taught you how to do it one way, and then 2 seconds later I'm showing you another quicker way. But the reason I'm doing that is honesty in advertising. This is what most Python programmers do. This is when you look at other people's code and when you look at libraries and things like that, this is what you're going to see. You're going to see a lot of with as. And with as, you know, allows you to work with objects, and you're going to see later when you get more sophisticated, you're going to be able to write your own classes and objects and make it work with as. But that's way in the future, and that gets a little more complicated. Right now, I just want you to see it, because what I'm going to do is I'm just going to line by line read that file and print it out. So you see 12, 23, and it's basically the same as numbers right there. See? So that's just a different way to read a file and do things as far as reading files is concerned, okay? So I wanted you to see with. Now you've seen with. You know the basics of file I/O. We are going to, what do I want to do? 1, 2, 3, right? And I want to get rid of this. Now we are going to deal with output files. This is the last thing I want you to see. We started with reading files. You open it, you read the data, then you close it. Well, what if during the process you wanted to write something to a file? You don't just read from them. You also want to create them and write to them. You do it the same exact way. As you can see here, I created a variable called OF, just for output file, and I assign it this, open outnums.dat, comma, W for writing. Now, you come here and you look. There's no outnums in this directory, okay? Nothing in my hands. There's nothing up my sleeves. And there's nothing in the directory where our code resides, okay? Then I use a with open, just like I did up here on top, and I read the numbers2.dat. And just like at the top, I read the first line and then I print it. But I do something a little bit different in the next 2 lines. I create a variable called bump, and I assign it the integer version of line. Because remember, these are sequential files. When I read in from them, I'm getting strings. So I turn it into an integer, and then I add 1 to it. So now I'm going to read in that 12. Bump is going to equal 13. I'm going to read in that 23. Bump is going to be 24. And what do? I write it to my new file. I say output file dot write, not dot read, like when we read our data in, dot write. What am I going to write? I'm going to turn bump into a string, so it's going to be 1, 3. And then, because I'm smart, I'm going to concatenate a new line so that when I create my new file, it's going to be just like this. 12, new line, 23, new line, 34. Only bump is 1 plus, so my new file is going to be 13, 24, 35, 46. Okay? I'm going to go through the loop, and I'm going to do that, and I'm going to get a new file. All right? Everything's going to work when I run this, right? Pregnant pause for you to figure out that I'm full of crap and it's not going to work. Watch. It read my file, 12, 23, 34. Okay, so it did the first part. Let's come up here and look. Outnums. Outnums has a file. We have an issue, though. I know the magic of Camtasia is letting me zoom in on that 0. It has nothing in it. I double click on it and I get nothing. Oh no, what happened? A little bit of inside baseball. When I am writing to an output file, I'm not writing to an actual file. I'm writing to a section of memory called the buffer, okay? All of that information, my 13 and then my 24 and then my 35, is sitting in the buffer. It doesn't get written to the file on the hard drive until I close. And the reason I do this and show it to you this way is because I really want to drive home the fact that when you're dealing with output files, you have to close them. Okay? If you forget to close something you've read from, creates a memory error, After a while, it'll go back to the system when your program stops running, blah, blah, blah. It's a softer kind of error. With output files, you have to close, because that's the way it's going to get written down to the hard drive and actually create this file. So now I'm going to rerun this program. It's going to overwrite outnums.dat and start me with a blank file. Then I'm going to go through this process of grabbing my numbers, adding 1, and writing them. And then when I get to the end, I'm going to say close. And that information in that buffer is going to go down to outnums.dat, and we're going to get a working file. All right, God, I hope so. All right, I ran it again. I get all of these numbers here. Okay, I'm in pretty good shape. I go here, and I look at outnums, only this time 1K. I've got some data there, so I think I'm in good shape. And as you can see, I'm good to go, because it added 1 and then wrote it, new line. Added 1, wrote it, new line. Added 1, wrote it, new line, all the way up. And you can see all of these values is 1 greater than all of the original values from numbers.2. Okay, so that's a chain you have right there where you read from a file, then you manipulate everything in the file a certain way, and then you write it to an output file. This output file can be sent to someone and say, here are the answers. Or you could use it as input for the next process that you want to do down the line. So you could use it for temporary storage for your data. Just think of these data files as like programs or storage for your code and your ideas and your logic. Data files is just where you store your data. So now you have permanent storage for everywhere. In the past, if you think about all the toy programs we've been learning with, we've created our data in the program. You know, create a list from 1 to 200, then square the numbers and find this and blah, 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 blah. Now we're getting to the real, because all the data you're going to use in your life is going to be on this, or an Excel spreadsheet, or something like that. Python has libraries where you can read in Excel spreadsheets and then access the data depending on the cell it's in. Okay? You're going to know how to do all of these things, so you're going to be fine. Just always remember to close your output files, and you're always going to be in great shape. All right? All right. Then, this is the part where I would say announcements. Blah, blah, blah. My head would get bigger on the screen, and I would run through a whole bunch of announcements. But I'm not going to do that, because I know I'm going to rapid succession get you a lot of videos this weekend. I'm going to get you video 3, probably tomorrow. And, you know, it's supposed to snow tomorrow night. If we get snow and I'm snowed in, I'll do videos all day long. I'll finish freaking Unit 4 tomorrow. So that's not going to be a problem. I'll definitely, no doubt, so I can give it to you by Sunday, going to get you the 3rd video for this unit. And then, as quickly as I can, I'm also going to get you, I'm probably going to be in the cave on Sunday. So in the cave, I'm probably going to do that 4th video where I do my own little homework assignment. I go off and grab myself a big bunch of random numbers, maybe 5,000, 10,000 random numbers, and I look through them and I see which ones are a palindrome. Okay? It's kind of easy with Python, you're going to see. And it's kind of similar to your assignment. I want to get you your assignment. It is my wildest hope to get you your assignment for the unit next Tuesday, let's say. And that'll give you like a full 2 weeks to work with it. Next week, I'm going to Baltimore. I'm going to my conference, the SIGSE conference for computer science education. It's down in Baltimore this year, and it's next week. It's Wednesday through Friday. So I'm going to be out of commission, and I'm not going to have time to sit down and do a lot of Python stuff those days. So I want to get you these videos, and I want to get them to you so you have them, you can watch them, you have all your resources, and then you can spend time as the practitioner working on the programs that you need to do for your assignments. Other than that, I'll do other announcements down the line, because I'm going to remind you about your midterm, and I'm going to tell you that Qasim and Kit are doing your grades tonight and tomorrow, and I hope to be sending back Unit 2 grades earlier, not later, so hopefully you'll be starting to get them on Monday and Tuesday as well. So we'll get all that stuff done. Don't worry about it. All right? Don't type this code in. I'm going to take this code. Actually, you know what I'm going to do. Hip, bip. Hip, bip. Look at that. There, you got a grand finale. And you got all of that code run together. I'm going to take this code, and I am going to put it on Sakai, so you are going to have it. All right? Then I'm going to get out of here. There's not another Islander game until Monday. Monday's President's Day, so they have a special 1 o'clock game versus the Wild. So basically, I'm just going to, for the next 2 days, just watch and pray for all the other teams in the Metropolitan Division to lose. Okay? Isn't that an awful way to live? But right now I got to root against the Devils and I got to root against the Flyers because the Devils are ahead of the Islanders and the Flyers, I think, are in third place right now. My problem is I think on Sunday the Flyers play the Rangers, so I would have to root for the Rangers, and that does not come naturally to an Islander fan. No, 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 no. All right, I'm going to get out of here. You be good, and I will definitely see you in a couple days. Probably, you know what? I'll save this and I'll give it to you tomorrow. So you'll get this on Saturday, and then hopefully you'll get the next one on Sunday. And then maybe I'll get you the assignments and the 4th video on Tuesday. That sounds like a nice little plan. Let's see if I can pull it off. I'll talk to you later.